This thing right here is the belt of an omnidirectional treadmill, and we need to figure out how we would move the belt in our own design. So let's figure this out. Now right here we have a dryer motor, and although it's powerful, its RPM is 1750, which is way too high, so we need to make a gear reduction so we can have a slower RPM. Now, I knew I needed a gear reduction, so my mind instantly went to a planetary gear, which is just a simple way of getting a gear reduction. I mean, honestly, it's not that simple, but if you put a few of these in series, you can get a great gear reduction. So I decided to 3D print this out to make sure that the idea would actually work.
Approximately 10 hours later.
Now, once I had everything printed out, all I had to do was put in a few bearings, and it seemed to work pretty well. Now, although I thought this was a great idea, I think I needed a little more gear reduction, and I also needed to change the rotation by at least 90 degrees, which I'll show you guys that reason later. So now, to change rotation by 90 degrees, I need to print out some bevel gears, so here those are now. Now, not only do these act as another gear reduction, but they also change the rotational movement by 90 degrees, which is quite useful when you think about it. After going through all those testing, I finally designed the End Gearbox, but I actually realized that this isn't going to be enough of a gear reduction, which is quite frustrating. Now, originally this belt was going to connect to the dryer motor, which would connect to the planetary gear, which would connect to the bevel gears, which I forgot to put into this, but it doesn't matter because we're going to have to change the whole gear reduction idea. Instead of doing gears, I think we're gonna go for a belt reduction, which simply accomplishes the same thing, but it's a whole lot easier and more robust. If I was to use this planetary gear, I would most likely end up repairing it a lot more often than I want to.
One eternity later.
Here's a rough idea of how this whole thing will work. It took a while, but I finally have a full design. So here's the dryer motor. It is connected to a small little pulley that sits right here, which then interfaces with the belt, which brings it to a large pulley, which then is connected directly. The large pulley and the small pulley are actually connected so that this spins at the same rate. Then this moves this giant belt right here, which then turns this thing, which goes into a small tube, and this will actually connect to one of the conveyor belts. So I think it gets the job done. I've already 3D printed this part, so let's go check that out. Alright, so here's the large pulley with a bearing in it. Now I actually already broke it a little bit, so that's pretty irritating. But the original idea was to have all these little nubs that fit into the pulley, but I couldn't get them to mesh correctly, which was super irritating. So what I ended up doing was flipping the belt inside out and just using the smooth edge to get more of a friction-based bond. So now when they turn, they're not directly connected by the nubs, but it still seems to work. So we'll have to deal with this for now until I get the other problem figured out. We've gone through a lot of progress this episode, getting the drivetrain worked out and how it's going to be functioning, and hopefully I can get this whole system built by build log 2, so keep an eye out for that. Anyway, have a great day, and I'll see y'all later.